Welcome to day 13, practice day. Today we will focus on reviewing and reinforcing the key concepts we have learned so far, particularly in inheritance, abstraction, and polymorphism. This session will help you practice applying these concepts in real world scenarios. Our learning goals for today include applying inheritance to build realistic class in hierarchies, demonstrating abstraction through the use of abstract classes and interfaces, practicing polymorphism by overriding methods and utilizing dynamic dispatch. For exercise 1, we will design a simple vehicle management system using inheritance. We will begin by creating a base class called vehicle, which will have properties such as brand, model, and year. These properties will be shared by all vehicles in our system. Next, we will create derived classes such as car, truck, and motorcycle. Each of these will inherit from the vehicle class and have specific attributes of their own. For example, the car class might have a seating capacity, while the truck class would have a payload capacity. We will also implement methods like start engine and stop engine and override them in the derived classes. Here's an example of the base vehicle class. It has public properties like brand, model, and year, and methods for starting and stopping the engine. Notice that we use the virtual keyword to allow these methods to be overridden in the derived classes. Now we move on to the derived classes. The car and truck classes inherit from vehicle. Each class has its own specific implementation of the start engine method. In the case of the truck class, the engine start message might be different from that of the car class, reflecting their unique characteristics. For exercise 2, we will implement abstraction in a library system. We will create an abstract class book which defines a method getDetails. Then we will create different types of books like textbook, novel, and magazine, which will each implement the getDetails method in their own way. Here's the abstract class book. It declares the pure virtual function getDetails, which must be implemented by any class that derives from it. The textbook class inherits from book and implements the getDetails method. The same is done by the novel class, but with a different message, showing how abstraction allows for flexible and dynamic behavior. In exercise 3, we will demonstrate polymorphism. We will create a shape hierarchy where different types of shapes such as circle and rectangle can calculate their area and perimeter. Polymorphism allows us to call these methods dynamically based on the actual object. Here we have the base class shape with two virtual methods, calculate area and calculate perimeter. These methods will be overridden in the derived classes to provide specific implementations for different shapes. In the derived classes such as circle and rectangle, we implement the methods to calculate the area and perimeter according to the respective formulas. Thanks to polymorphism, we can call these methods on a shape pointer and the correct method will be called based on the actual object type. In exercise 4, we will explore abstract classes and interfaces. We will define an interface payment processor, which will include methods like process payment and refund payment. Then we will create classes such as credit card payment and PayPal payment, which will implement these methods. Here's the payment processor interface, which defines the methods for processing payments and issuing refunds. Any class that implements this interface must provide its own implementation of these methods. Now let's wrap up the session with a discussion. Reflect on the common challenges you might have faced during these exercises, and let's discuss how inheritance, abstraction, and polymorphism all contribute to building more flexible and maintainable systems. Before we finish, here are some practice tips. Focus on creating clear and concise class hierarchies. Emphasize the importance of polymorphism for writing reusable code. Experiment with real-world examples to solidify your understanding of these concepts. And finally, here's a motivational quote to inspire you. The best way to predict the future is to create it. Abraham Lincoln. Keep pushing forward and you will create a successful future for yourself as a programmer.